Okay, this is word problem number 6 on page 583, and in this problem we have two ships leave the same port, so we'll put that as point P for port. And one of them, they leave at the same time and they travel straight line courses, and one goes 10 miles an hour and the other 25 miles an hour for 2 hours. So if this one goes 2 hours, say at 25 miles an hour, it's going to make a distance of 50 miles. And if this one goes 2 hours at 10 miles an hour, it's going to go a distance of 20 miles. And this was the tanker, because this was the slower one. Yeah, so we'll call that T. And then this is the cruise ship that goes farther, going faster. It's not really drawn to scale. So what they want to know is, at the end of the 2 hours, what's the difference, what's the distance between the tanker and the cruise ship? So trying to find that side right there. Or I do know it, actually. That's not the problem. The problem tells me that they're 40 miles apart, and the question asks, what's the angle that they left at when they left port? What was the angle between their two courses? So this is a case for using law of cosines, and I can use the form of the law of cosines that lets me find the missing angle when I know all three of the side lengths. So we'll just call that angle A or whatever. And so I'll use the cosine of angle A will be equal to this side squared plus this side squared. So 20 squared plus 50 squared minus the side opposite angle A squared. So minus the 40 squared all over 2 times the product of the two sides that I know. So when I simplify this, my numerator, I will get 1,300, and the denominator over 2,000. And that's, if you want to reduce that, that's fine. It's like 13 over 20. So that's the ratio of the leg lengths in a right triangle of adjacent over hypotenuse. So in order to find the measure of angle A, now I use the inverse cosine and look up the angle measure that goes with this ratio. And when I do that, I'll get angle A to the nearest tenth of a degree is 49.5 degrees. So that would be the angle right in here, which I just guessed that it was acute, but it's 49.5 degrees. And that's it.